Hi guys, welcome to the Numpy Essentials lecture part 1. As a fundamental package for scientific computing, Numpy provides the foundations of mathematical, scientific, engineering, and data science programming within Python ecosystem. Numpy's main object is the homogeneous multidimensional array. In this lecture, we will go through the range of important concepts and built-in functions that we will be frequently using in the coming sections. As usual, this notebook is a reference to the video lecture. You can always explore this notebook if you need help. I hope that you have already installed NumPy. Let's move on and create a new notebook to explore more about NumPy. Go to File, New Notebook, Python 3, and here we are in the new notebook. As we have already installed NumPy, we have to import this library if we want to use it. So to import, we simply follow the command import NumPy as np, and this is a usual way of importing NumPy as np. Let's run this cell. So NumPy has many built-in functions and it has lots of capabilities. In this lecture, we will focus on some of the most important and key concepts that we will be using in this course. Let's start with NumPy arrays. NumPy arrays will be the main concept that we will be using in this course. NumPy arrays essentially come in two flavors: vectors and matrices. Vectors are strictly one-dimensional array. However, matrices are two-dimensional arrays. Matrix can still have only one row or one column. We can create NumPy array from Python's data type, like from tuples and lists. Let's create a Python list first. MyList equal to, say, -1, 0, and 1. Let's run this cell and check how the MyList look like. Let's check its type as well. So let's run this cell. So we have MyList -1, 0, and 1, and its type is Python list. To create a NumPy array from Python's data structure, we use NumPy's array function. The NumPy's array function can be accessed by typing np.array because now we have NumPy as np. So we can say np.array. We don't need to say numpy.array. We need to cast our Python data structure, which is MyList, as a parameter to the array function. Let's try to do this thing. MyArray equal to np.array. Let's pass in MyList. Let's check how this MyArray look like and also check its data type as well. Let's run this cell. So the MyArray is -1, 0, 1. This is same as this list here. And now this MyArray is numpy.ndArray object. So we have created a NumPy array using Python's data structure list. Let's create a two-dimensional NumPy array. We need to cast list of list to generate this thing. Like we can say my matrix equal to 1, 2, 3, 4, 5, 6, 7, 7, 8, 9. So we have my matrix as a list of lists in Python. Let's see how this my matrix look like, and we can check its type as well. Let's run this cell. So my matrix is an array of arrays and its type is list. Let's pass in this my matrix to np.array function and generate a numpy matrix. So matrix, let's call it 1, our first matrix, np.array, and pass in my matrix. Let's run this cell and now check how the my matrix look like, and we can check its type as well. type. So here it is. So we have a two-dimensional matrix and its type is numpy array. So far we have used list to create numpy arrays. We can use tuple instead. So let's create a tuple, my tuple, equal to, we can say -1, 0, and 1, the same one. We can pass in my tuple to my array. We can say T stands for tuple, my array tuple, equal to np.array, and we can pass in this tuple here. Run this cell and let's see how this my array T looks like, and we can check its type as well. So we have created numpy array using tuple, and this, and here it is -1, 0, and 1, and its type is numpy array. So we can create numpy arrays using its built-in function as well. Most of the time we use numpy built-in functions to create arrays because they are much simpler and faster. Let's discuss the first function that we can usually use to create numpy array, arange. Arange is much similar to Python's function range. Its syntax is similar. We give start point, stop point, and then we give a step. It returns evenly spaced values within a given interval. So we can't call this arange function without saying np.arange. As usual, we can check its documentation using Shift tab, and here it is. Start point, stop point, and step. So if you want, you can read this documentation with some examples. Anyhow, so let's pass in 0 as a start point, say 11 as a stop or the end point, and we want step 2. And let's run this cell. So here it is. We have a numpy array with 0, 2, 4, 6, 8, and 10 with step size 2 from 0 to 11. We can give the step and data type as well. Like, let's copy this one, paste it here, and tell this function dtype equal to float. So what we want? We want array of floating point numbers. So let's run this one. So instead of 0 to 4, we have 0 point, 2 point, 4 point, because we have mentioned we want data type as float. So the next very important built-in function is linspace, L-I-N-S-P-A-C-E. We can't use this without np dot, and linspace returns evenly spaced numbers over a specified interval. We can check its docstring with Shift tab, and here it is. We have a start point, stop point, some other parameters, and data type as well. Let's pass in 1 as a start point, 15 and 15. So what we want, start from 1, end at 15 with 15 equally spaced points between 1 and 15. Let's run this code here. So here we have 1, 2, 3, 4, 5 up to 15. So we have 15 equally spaced points in our output. Let's check another very important parameter in Linspace. Shift tab, RET step, and the default value is false. What RET step is? If RET step is true, it returns the step size. Let's pass in true. Copy this one, paste it here, and pass in another parameter, ret step, and run this code again. So now we have 1.0 in addition to this array. So this 1.0 is because of this parameter, which is telling us the step size in this array is 1. Let's consider another example, and instead of 15, pass in 30 here and run this cell. So now we have different step size here. Let's pass in the ret true as well, and now here it is. So we have the step size here 0.4872 and so on. Now instead of 1, the step size is different because we want 30 points in this case. So one thing not to confuse between arange and Linspace is arange takes third argument as a step size. Let's check this thing. Start, stop, and step. Let's check the documentation of Linspace. So whereas Linspace takes third argument as a number of points we want, default is 50 here. So let's move on to next very important built-in function, zeros. We need to call with np again. Zeros create an array with all zeros. Like if we want np.zeros and pass in 3 as an argument, it's creating array with 3 zeros. We pass in say 10, it's creating array with 10 zeros. And if we pass in a tuple with say 4, 6, it will create a two-dimensional matrix with 4 rows and 6 columns. So now we can create a two-dimensional as well as one-dimensional array using 0. Same as zeros, there's another built-in function np.ones, O-N-E-S. If we pass in 4, it generates array with 4 ones. And if we pass in as we pass in 4, 6 in zeros, if we pass the shape here, it's returning the two-dimensional array with ones. So it's very similar to zeros. Ones and zeros are very similar. The only thing is, like, zeros is giving us all 0 values, ones is giving us all 1 values. So let's move on to another one, I. We need np.I. So I creates identity matrix, and identity matrix must be square matrix. This is useful in several ways in linear algebra problems, and I hope many of you guys are familiar with identity matrix. So EYE or I return two-dimensional arrays, ones along the diagonal and zeros at all other places. And in identity matrix, we have ones along the diagonal. So let's check its documentation. So it needs n as a parameter, where n is the number of rows in the output. Let's pass in 4 here. So we have created 4 rows, and identity matrix must be a square matrix. So it has 4 rows and 4 columns and ones along diagonal, and all other places we are getting zeros. So moving forward to random number creation in NumPy, we can also create array with random numbers using NumPy's built-in function in random module. Random module we can access with np.random. Let's talk about the first function in this random, rand. So rand or rand creates an array of given shape and populate it with random samples from uniform distribution over 0 and 1. Instead of np, we need to use np.random because rand is a part of random. So np.random.rand, and let's pass in 3 here, and what we are getting 0.02, 0.31, something 94, and 0.03. So we are getting 3 elements, one dimensional array because we passed in 3, and all these numbers are between 0 and 1. So let's copy this one here, paste it here, and check its docstring. If we scroll down, we see another example here, np.random.rand32. So let's pass in the same 32. So now what we are asking, generate a random number matrix with 3 rows and 2 columns. Let's run this thing here. So we have 0.39, 0.53, so 1 row, 2 row, and 3 rows, and we have 2 columns here. So there is another very useful and similar function in NumPy, RandN. RandN returns a simple form of standard normal or Gaussian distribution. So if we want to use RandN, let's copy this one here, np. We have to access with np.random.randn. Let's pass in 2 here, and now it's generating 0.17 and minus this one. So let's pass in a 4 by 4. Now we want a matrix with 4 rows and 4 columns. So it's generating a matrix with 4 rows and 4 columns. So what we said, it generates a standard normal or Gaussian distribution of the sample. So let's talk about another useful function in the same class or same category. So RentInt. So we need np.random. Here it is. So RentInt, let's see, 1 and 100, and run this code here. So what this is doing, RentInt takes low and high value here and generates a single random number between 1 inclusive and 100 exclusive. So if you are only giving these 2 parameters, it's only generating 1 random number. Let's look at the documentation string. So it has low, we have 1 here, high, we have 100 here, returns random integer from low to high exclusive. So what these parameters are, the third one is size. Here it is, size. So if there is no size, default is none, in which case the single value is returned. So we're not passing any step, any size, and it's returning single value. And it's random number generation. Each time it's generating different output, 50 here, 73 here, and anything 6 here. Let's pass in the size. We want 4. Now it's generating list of 4 random numbers because we are asking him to generate 4 random numbers. What if we pass 10? It will generate list of 10 random numbers. So what if we want a matrix in the output? We can do this thing as well, like we want a matrix 2 by 3. So now it's generating a matrix, 2-dimensional array, 2 rows and 3 columns. We can pass in 4 by 4 and it's generating a matrix with random number, 4 by 4 matrix with random number. If we run it again and again, the numbers are changing because we are generating random numbers. So these are few very important functions that we have explored. Let's move on to array methods and attributes. Some very important methods and attributes we need to know here are reshape, max, min, argmax, argmin. We are going to explore all these methods now. So let's generate an array using arange np dot arange. Let's pass in 16 and generate another array with say RentInt, a random number, np dot random dot. We can press tab here to autocomplete. So there are lots of options. Let's write it rand, and now we have few options. Pass in 0, 100, and how many we want. We want 10. And let's see how the output look like for array arange and array RentInt. So we have two arrays. We have used arange and RentInt. So 0, 1, 2 up to 15 and some random numbers. Let's use a built-in function, reshape. Reshape returns an array containing the same data within new shape. Like we have an array here and we want to reshape that array with say a 4 by 4 matrix. So what we can do, we can take this array, call this function on this array dot reshape. So array arange dot reshape, and we can tell the function what type of shape we want. We want 4 by 4, and now it's reshaping this 1-dimensional array to 2-dimensional array of 4 by 4 shape. So the next one is max and min. What if we want to know what is the maximum number in this array and what is the minimum number? It's very simple. We just call max on this array. Let's take array RentInt here and we call min on this same array. Let's run this cell. 87 and 13, and if we look at this array, we have 87 the maximum one and 13 is the minimum one. So next important one that we are going to use in our course, argmax and argmin. So argmax and argmin are used to find the index locations of maximum and minimum values in array. Like let's say we want to know what is the index location of 87. Then what we will do, we will use argmax on array RentInt. So let's copy array RentInt, call the function argmax and just run this thing. So we have 87 on 7th location in this array, 0, 1, 2, 3, 4, 5, 6, 7. So this is the 7th location. So argmax is returning the location of maximum number in an array. And the similar way, location of minimum number in array. So we call it argmin. So 8. If we look at this thing, 0, 1, 2, 3, 4, 5, 6, 7, 8, 13 got location 8 in the array. So let's move on to some other very important concepts. Like if we want to know the size of array, if we want to know the shape of array, if we want to know what type of data it has. So let's use the same array, copy it, paste it, and run the cell again. So now we have array A range from 0 to 15. And what if we want to know the shape of this array? We simply call shape. And here it is. It's 16 element one dimensional array. What if we want to know the size of this array? We call another attribute size. So it has 16 size. Its size is 16. It has 16 numbers, 16 elements. What if we want to know its data type? So the same way we call dtype, and its data type is int. Let's reshape this array using reshape, say 4 by 4. Now we have two-dimensional matrix, and again check its shape. So it has 4 by 4 matrix. So we are rearranging this array 4 by 4 and then again checking it's returning the shape of this new array. We can call it like 16 1, like we can reshape to 16 1, and now we have 16 1 array. We can do it 116 as well, like lots of options here, and then we have the different shape. So we are done with the part 1 Numpy Essentials. We have learned some very useful functions, how to create arrays, how to use different attributes on the NumPy arrays, how to generate random numbers, and several other very important functions. So let's move on to the next section, and in that section we will learn some other important NumPy concepts. See you in the next lecture. Good luck.